Okay, good afternoon, everyone. Thanks for joining us on our call today. My name is Nicole Quincy from Transcat, and I'll be your moderator this afternoon. Our webinar topic is electrical measurement safety. It's being presented by Kurt Geeting from Fluke. Kurt is a Fluke sales engineer who supports Eastern Pennsylvania, New Jersey, New York City metro area, and Central New York State. He has worked in the test equipment industry for 33 years. He is certified as a level 1 thermographer, as a level 1 vibration specialist, and is the Fluke trainer for the International Brotherhood of Electrical Workers. He has been with Fluke Corporation as a regional sales engineer for 17 years. We expect the presentation today to last roughly 30 to 40 minutes, and then we'll answer any questions that have been submitted. During any time of the presentation, you can send questions through the question box to the right in your webinar controls. I also want to mention that this webinar is being recorded. Each of you will receive a follow-up email with a link to the recorded webinar and the slides of today's presentation. At this time, I'm going to turn the presentation over to Kurt.
Good afternoon. Appreciate everybody's time here today. My name is Kurt Geeting, again with Fluke Corporation. We're looking to enlighten you folks in terms of electrical measurement safety. We at Fluke have been doing this for almost 20 years now. And this is a regular seminar that we present to customers within their facilities as well as online. So we're going to start off with a basic premise. And this is one that I ask customers all the time. Have you ever gotten shocked by anything other than your paycheck? As funny as that sounds, it's not something you're expecting to have happen to you. Certainly not part of your job description. Your boss doesn't say to you on day 5 you're going to get shocked. And so we wanted to make sure that everybody is well aware of what that hazard looks like in terms of the amplitude of the current. So as you can see from the chart, starting at 1 milliamps, 1,000th, 100,000th of an amp, all the way up to 2,000 milliamps, or 2 amps, this electrocution and shock process happens. So really quick, the important points to know, at 3 to 5 milliamps is where a GFCI would trip. And no surprise there, at 5 milliamps is where you're actually going to start to feel the shock. Roughly around 6 to 16 milliamps, then when we say about 10 milliamps, you lose muscle control, so your hands and your muscles would lock and spasm and hold on to the energized conductor so you could not let go. Obviously after that, respiratory failure starts to occur, so you can't breathe or you can't yell out. And somewhere between 100 and 2,000 milliamps for 5 seconds across my chest cavity will stop my heart. So relatively low current, and it is the current, not the voltage. So keep that in mind when you're dealing with circuits that you are both investigating as well as troubleshooting. So obviously, oops, I'll go back one slide, my apologies. Shock can occur where there's a sufficient amount of current through the skin, the muscles, the hair, and then obviously shock can cause electrocution and death. So again, it's the current, not the voltage, and it's relatively low current. For those who may not be informed about this, it doesn't take a whole lot to stop your heart. So the end lesson there is electricity really needs to get respect that it's due. And unfortunately, many times in our industry, that is not the case. Arc flash is the next occurrence that we're on the lookout for, and that's basically where you have a connection phase to phase or phase to ground to create a short circuit. Now, the flash portion is a very short duration. That is an actual flash of light or an arcing, if you will, typically duration under a second. We're showing the example of 2 test leads that are very close proximity on a higher voltage circuit, and obviously they're arcing over through the air through the test leads. If this arc continues for longer than a second, we have what's called an arc blast. An arc blast is a complete connection of those 2 phases or phase to ground, and quite a few things are obviously going to happen at this point in time. The most intense of which is going to be intense heat and fireball and shock wave coming at the end user. We're going to have blinding light, we're going to have smoke, we're going to have the potential of being in contact with an energized component. As you can see by that image there, quite a bit of damage. Keeping in mind, obviously, in our industry, this is going to happen as with close proximity with a piece of test equipment. So the end user is in very close proximity to this occurrence when it happens. And unfortunately, that's when many things can occur, even death. So we're looking at all the causes. We're going to talk about the first one, what we refer to as transients. So why would an arc flash and arc blast happen? Many times this is high-speed noise, or spikes, if you will, that are traveling as loads are switching on and off, or if you have utility load switching, or if you're using things like adjustable speed drives or variable frequency drives, as they're known, and obviously lightning strikes. High amplitude, very short duration, and have the ability to overcome a piece of equipment or test equipment that does not have the proper input detection and causing an actual arc or short within the tester itself. So the amplitude of these can be 8,000 volts or higher. This is riding on top of a 480 volt or 240 volt sine wave or waveform, if you will. So the amplitudes obviously are extremely high and very, very fast. What causes these? Well, real simply, occurrences where we're moving things. So I'm racking in a circuit breaker, and I might actually have something touch a live bus or live connection if I'm racking it in. Loose panel wiring. Somebody didn't do a proper job of tightening a conductor, and it shorts out across the face of that panel or to ground or to another conductor. Removing panel screws. Things are falling, coming in contact with live circuit. Hand tools. Very typical, and this is one of the reasons why you should be using insulated tools and obviously insulated gloves. So if you're accidentally coming across two phases with the end of a screwdriver, obviously that's going to cause a dead short. Incorrect test probes are a big one for us at Fluke. We've seen quite a few of the tips of these blown off or misused. So obviously if I'm slipping and I'm, let's see, on two screw terminals with a very small barrier between the two, and I accidentally slip and these two test probes cross each other as they're touching two phases, so I can cause that incident to occur. And then misuse of test equipment. So the biggest single misapplication we have with things like a multimeter would be hooking it as an inline series measurement, as a current measurement, and actually doing it as a voltage measurement across two phases. And we'll get into that a little bit more here in a minute. Testing continuity in a live circuit with a meter that's obviously not designed to be able to handle that. And then, again, accidentally shorting two phases with the test leads. So what we're trying to be in compliance with, and I'm sure everyone here on the line is what's referred to as NFPA 70E. That's the National Fire Protection Association Code 70E. This is an insurance industry standard, and really setting the safety standards and specifications for safety-related activities on energized circuits. So with that in mind, part of what gets set forth is what's called safe working distances or flash limit approaches. And as you can see, as the worker approaches an energized or open panel, the area that in which he can operate in without protective clothing is set. So inside those boundaries, a certain level of PPE or protective clothing has to be worn, and outside those boundaries does not. So most electrical workers, due to the fact that they're using our test equipment, and as an example, that gentleman's holding a little Fluke meter in his hand, if you see, because of the length of the test leads being 4 feet long, and most arc flash zones being at least 5 feet out, by the nature of being inside of that area and making those measurements with use of his hands, would be considered to be inside that restricted space. So, oops, my apologies, wrong way. So, what level of PPE, what level of protective clothing is required? Well, the panels would be rated based on the calorie rating and the arc rating and the PPE category required. And as you can see, as we go up in the calorie rating, so do the layers of clothing as well. This should continue to along the lines of having face shields, insulated tools, insulated gloves, hearing protection, eye protection. So there's quite a few things that the end worker has to be putting on in order to be considered in compliance with NFPA 70 with the amount of PPE required in that area. We at Fluke do not sell PPE gear. This is something that's readily available in the market, and I certainly would love to have a conversation with folks at Transcat about your needs for protective clothing. So test equipment is now considered part of PPE. A meter's first job is to protect you. We have been active at Fluke in getting this instituted into the standard. And as you can see, the meter has to be rated for the circuits and equipment for which it's connected to. It has to be used in the proper environment. It should be visually inspected for defect or damage. And the installation of protective tools, including the voltage tester, shall be verified by test and inspection prior to going into the circuit. So these all fall under the category of the international standards for low voltage test equipment. What's low voltage in the marketplace? It's 1,000 volts and below. It's considered low voltage. And that's the market that we at Fluke are in. So we define this by category, and with that, we use pictures. The easiest way to describe it is to show where. So the three categories we're going to talk about, and there's actually four, but there's three we're going to show here, are Cat 3, which is three-phase with the utility connection, and any outdoor mains. So for those folks who are working outside in electrical environments, this is considered a Cat 4 environment. So whether I'm on the roof or I'm outside working an electrical connection, this is Cat 4. Cat 3 would be my three-phase distribution in the world that most electricians operate in terms of voltage amplitude. That would be from 208 volts up to 480 volts here in the United States. And if you're in Canada, that would go all the way up to 575. Single-phase receptacle loads, or receptacle loads, which is obviously plugging into an outlet, would be considered Cat 2, and then Cat 1, which is not shown, is the output side of a 24-volt or 12-volt DC power supply. So based on the environment where the meter is going to be used, would have to have the right category rating on the face of the meter to show that it's appropriate for that application. So we at Fluke are trying to do everything we can to meet or exceed those industry standards, and obviously in full compliance with NFPA 70E and IEC 61010, which is the standards for low voltage test equipment internationally. And for the most part, again, most electricians are operating at up to 480 or 600 volt three-phase circuits. So the typical application, majority of the applications fall within that Cat 3 600 volt range, but certainly we have a large contingent of customers using Cat 4 outside environments. So first the category, then the voltage. So we're looking to make sure that the meter can handle the full voltage range of the category you're going to be using it in. Most meters now minimally have a rating of Cat 3 600 volts. That's considered the minimal acceptable standard now in most environments. And the higher the category rating, the higher the transient protection in the meter as well. As you can see, a Cat 3000 volt meter can withstand an 8 kV transient. And by the way, that's on every range in the meter. And it is multiple times that we actually subject the meter to that. And a Cat 3 600 volt can withstand a 6 kV or 6,000 volt. So there's a fair amount of over voltage protection now afforded the end user inside this meter when you have the Cat ratings on them. What you'd be looking for would be the ratings on the input jacks. So on a multimeter, obviously, right between the volt and the common, as we can see in the exploded view to the left. If it's on a clamp on, it might be at the bottom of the meter, but they need to have markings there, none the same. So since the standard started in 1997, we at Fluke have been putting category ratings on our meters since that point. It actually started making meters in 1948, so we've been at this for 68 years now, and obviously made quite a few meters, as did everybody else, prior to the standard coming into play. So what does that mean? It means that favorite old Fluke 77 that you bought back when it came out in the late 70s, early 80s, it's still serving you well. It's a great meter. Don't throw it away. Keep that handy, but you're not really allowed to use that at work anymore because it doesn't meet and is not in compliance with NFPA 70E because there is no Cat rating on it. Or in the case of an older 70 Series 3 meter is to the right, it's Cat 2 600 volt. And again, the minimum acceptable rating now is Cat 3 600 volts. That's what is considered in compliance as a minimum acceptable rating. Okay. So the other part we're looking for, and that you should be looking for as an end user, is the third-party safety rating. And we deal with 3 different safety agencies because we sell the products worldwide. So UL here in the United States, CSA in Canada, and then TUV in Europe. And some meters have multiple safety ratings, depending on what areas of the world that we're selling them in. But minimally, you should have at least one. And the idea there is that it's not just us saying that we meet the standards, but we are actually listed to and not just designed to a standard. So it's actually been tested as a developed product by a third-party safety lab. This is your assurance the meter meets or exceeds the standards. Obviously, most customers do get a manual. Whether or not they read them, we're not too sure. But all manuals are available with the products, and all manuals are available from at least Fluke to be able to be downloaded from our fluke.com website. Please do refer to that for any safety instructions, so everybody is clear that this is not complete safety training. Please read and understand the manual that came with your meter. Non-contact voltage detectors are interesting. We sell a lot of these. It's a quick verification tool. It beeps and or lights up or a combination thereof when there's the presence of voltage. It is certainly used as a first-line detector. It is used to test the absence of voltage, which is many times what people are using meters and clamp meters for. But still, one needs to put PPE gear on, and the meter still needs to have a category rating, which they all do. And again, minimally Cat 3, 600 volt. So even though I'm not physically making contact with the circuit, I'm only coming into proximity of it, I still need to make sure that the meter is properly rated, and I'm using it the same way I'd use any other piece of test equipment. So the sequence for testing looks like this. You should be finding a live circuit associated or close by that I can test and verify the operation of my meter. Go into the target circuit, which we're assuming you are de-energized and are looking to ensure that it is dead or de-energized. And then we go back to the live circuit again. So it's a three-point method by which to verify my contact or non-contact voltage tester is in fact working. The idea is obviously I'm trying to have 100% confidence that that de-energized circuit is in fact de-energized. And this is the easiest way to figure that out and know that my meter is working and telling me the truth. So we have many customers now that are telling us I don't have a reference circuit. I'm operating a switchgear cabinet, or I am outside a transformer. So what we've launched at Fluke is a new product here in the last year called the PRV240. This is a little handheld reference source that also operates and hangs off a magnet and has the ability of producing 240 volts AC and DC to verify the operation of any meter prior to going into a known circuit, or unknown circuit, I should say. And if you're interested, the folks at Transcat can certainly talk to you about this. If there's an interest in getting specifications on these and possibly looking to obtain one of these, they can certainly help you out with that as well. But that's why we released the product, because we do have customers that have no ability to verify against a known circuit. There's nothing in the immediate area that they can test their meter against. Test leads are a big source of weakness. They are probably the weakest link in any multimeter clamp meter system. You see a lot of folks wrapping their leads around their meter. I see that quite a bit. And we're not really doing them any favors when we do that, right? If you keep pulling on the leads in a particular direction and wrapping them around your meter tightly, you're basically going to be breaking the small conductors inside those wires. So we're ensuring that they have the proper rating. We're ensuring that they have shrouded connectors and finger guards. We're making sure that they're not melted, that the insulator is not pulled away, that the probe tip's not loose or broken off or blown off, and we'll make sure that they're using the proper environments for which they're designed. What we're very big on at Fluke is the idea of testing your leads as well as your meter, and we'll get into that in a little bit. So minimum amount of exposed metal. So most test leads traditionally have 3/4 of an inch to possibly an inch worth of metal tip hanging out at the end of the lead. What we've come up with at Fluke is a set of leads called TL175. These are the ones that are pictured to the right. They're called safety leads. And the idea is you can actually twist them to have an external shroud surround the top of the meter, as is evidenced by that red probe. When I'm in very tight environments and I'm trying to minimize the exposed length of the test probe. And in those environments where it's okay to have extra length, I can twist it back and have it exposed back. So both the red and the black probe would both extend in both directions, and allowing us some additional protection in the event that you've been drinking too much coffee and have a shaky hand and you slip on the circuit. I don't have very much probe tip, so I can't possibly short two of these out together at the same time. So the bottom line is safety first. Lockout, tag out, work on de-energized circuits, wear all the protective clothing, don't work alone if you can at all help it, and practice the safe technique of connecting the ground lead first and the hot second. Just connect the hot lead first and the grounded second. And doing the 3-point test method, doing testing against no live circuit, a dead or supposedly dead circuit, and then a live circuit, to verify two things: A, my meter is working, and B, that circuit is in fact dead. And that will give you the 100% confidence that you can go ahead and work in that de-energized circuit. So we put a lot of protection in the meters. Obviously, as you can see, we at Fluke put 10 to 15% exclusively for protection, so that's quite a bit. Considering the price of a Fluke meter, and then multiplying by that amount, you can get an idea how much front-level protection is built into the product. And it is for you, the end user, that we're doing this. We do not want you to have an accident. We do not want you to get hurt while you're working in that environment, and we're trying to put every level of protection in the meter to protect you, the end user. So if there is an accidental misapplication of the meter takes the hit, and the end user walks away. That is the thought, and that is the design of the meters, but of course we can't help people from doing things that they shouldn't be doing. So, common misapplication errors. These are very typical ones, and we see quite a bit of this. So the first one is I am hooking my meter, as it is up on the left corner, as a series connection. I have my hot lead is the amp jack or the milliamp jack, and the black of the common lead in my common jack, and I'm hooked in across in a parallel way across two phases of AC. This could be something as simple as looking at the neutral and the hot on an outlet. But I'm basically hooked in series, so I'm causing a dead short to appear in the meter itself. The second way that's illustrated at the bottom is measuring ohms of continuity on a live circuit. So I was in what I thought was a de-energized circuit. I have my meter in ohms, and now I'm seeing voltage traveling into the meter. We don't have any issues with that today in any of the Fluke products that we now have Cat3 ratings because of the over voltage protection. But in the older meters, and particularly older analog VLMs, this was problematic because they were not designed for that, and in many instances that would cause a bit of an explosion. Sometimes taking a portion of the meter out or the entire meter out and putting the end user at risk. So these are pretty typical misapplications we see on meters these days. And the protection factor afforded in the meter is now allowing for this to a certain degree. We have, however, issues where folks do not use the original fuse that was designed and supplied with the meter. And there's a typical application. These are not computer-enhanced images. These are actual images from our service lab at Fluke. Somebody's decided to put an older glass-style automotive fuse into the slot where the original fuse was supposed to be. And obviously, when called upon to be a fuse on an AC application, did not perform as such, and there was an explosion. And the second occurrence was a lower rated fuse. It was rated for 600 volts or 1,000 volts, but rather 250. And it didn't open up in time. And unfortunately, again, this person used the wrong meter on the wrong circuit and or with the wrong fuse, combination thereof. And unfortunately, did not escape unharmed. He clearly, or she, was not wearing protective gloves, and his fingertips or their fingertips burned into the plastic probes, and they weren't burned. So very common misapplication of a piece of test equipment can result in not just electrocution, but severe upwards of third-degree burns on the hands and on the arms, because think about the concept of the meter. I'm holding those leads right up into the circuit itself, so I am right there in that restricted zone. So we put high-energy fuses in meters now. We've been doing this for quite a few years. These are designed for fault currents of up to 10,000 amps in a very short amount of time. and interrupt that fault in the event I've miswired my meter, and that fuse will open up and stop that arc blast. So we're very particular about this. We supply these, and these are the standard fuses that have to be supplied into the meter in the event that you would take out a fuse. You are highly suggested, if not impaired, to go to your Fluke distributor, in this case Transcat, and buy our replacement fuses. Not all fuses are created the same, and not all fuses are created equally, and they're not tested. These are tested and rated UL rated fuses, and can again interrupt up to 10,000 amps of fault current. So the common misapplication, again, short circuit hooked into the current jacks, while measuring voltage phase to phase. The fuses are protection, coming in contact with AC or DC power while on ohms or continuity. And again, the ability to protect it up to the full rating of the meter, 600 or 1,000 volts, depending on the category rating and the voltage rating. But not using it beyond that. So none of our test equipment at Fluke is really designed to be used to measuring energized circuits beyond 1,000 volts or 600 volts. So obviously I'm not going to hook to the primary side of the transformer. For those who are doing inline current measurements, many times we find where they have been when they were originally wired was for application of a 4 to 20 milliamp process loop. And so that demands shutting down the loop, wiring the meter in series, turning it back on, and making our measurements. So that's why those leads would be there many times, and the end user would forget that he left those between a milliamp and the common jack, and then take the switch position on that dial and flip it from milliamps over to volts AC at the 9 o'clock position, and then take the leads and measure, let's say, the input of the power supply at 120 volts, and then pop the fuse and or the breaker and or cause the possibility of an explosion to occur. So that's many times how that happens. So we at Fluke has designed a product for this very application called a 771 milliamp process clamp. And the idea is, rather than having to break the circuit and wire myself in series, so how about the idea that I can take the shielded twisted pair of wires, pick them apart, grab onto one of those two wires with a very small clamp on, and measure current all the way down to 10 microamps. So we can do a 4 to 20 milliamp measurement without having to break the loop, and also avoid that whole potential of miswiring my meter through that and blowing a circuit and or blowing a fuse or putting myself in harm's way. So that, again, is a product that you folks obviously can talk to the folks at Transcat about. It's a very, very popular product. We have several, 772 and 773 also output a voltage and or a current signal as well. So using the multimeter in the ammeter mode obviously requires, if I did that, I'm probably lose my fuse. So the way to test that is you can take one test lead, put your meter in the ohms position, 12 o'clock dial on most of the meters, and take one test lead and jump it from the volts ohm slot right over to the amp slot, or take your probe tip and put it down there, and we're going to read the resistance of the fuse. If the fuse is good, there's a resistance. If the fuse is blown, there will be an open, and we'll show it as an OL. So that's how we can do that. So again, what we're looking for is the idea of working within the boundaries that are acceptable, making sure that we have the proper PPE on, making sure that we are operating safely. What we at Fluke have been busy doing in the interim in the last few years is launching a number of wireless tools that eliminate this altogether. So the idea is, what if I could take my meter and put it down inside that panel and either take the display off and read it from outside the circuit with the meter mounted inside the panel door, so I can get to take off my PPE or potentially get to take my PPE gear off. And then the other way is use it with a mobile device, what we call Fluke Connect enabled. So we have now started to put an FC, as in Fluke Connect, label on all the new meters that are coming out that are either Bluetooth and or wireless that will work with Fluke Connect. This is a free application. It's on both the Apple as well as the Droid websites. It's also on Google Play. And you will allow you to talk to that device from a distance of typically up to 65 feet away. You can talk through the panel door, gets myself out of the arc flash zone, allows me to take off PPE gear and operate in my normal work clothes or street clothes. and puts me in a very safe environment and out of harm's way, so to speak. So here's a typical example of a gentleman who has a panel door open with 3 plant meters, and he's talking to with a multimeter called a 3000 FC. This is a device that will go out and talk to other portable modules. We offer voltage and current modules that are specific to one task, and they can report out to either a multimeter or to the Fluke Connect application, which is operating on my mobile device. But in addition to that, we have been doing this on quite a few other products. And one of the big applications we hear customers want to do is I want to look at all 3 voltages and all 3 currents at the same time, simultaneously. I'd like to do it without having to have all my PPE gear on. I'd like to do it on the other side of the panel door, and I'd like to do it through my mobile device like my phone. And to that, our response was a model called the 1736 and 1738. It's been on the market for about a year now and very popular, and it allowed me to record and actually run off the circuit itself. So the beauty of that is I can actually power the instrument across any 2 phases, and I don't have to worry about an extension cord, and I don't have to worry about making the panel door hanging open with that extension cord hanging out there, but rather have it get powering right off the circuit itself, and we can do that for up to 3 months of recording time. So Fluke Connect is an application. It is free. It allows you, the end user, to record, to be able to share live, to be able to document, and to be able to trend your measurements over time wirelessly and paperlessly. And it is all patented by Fluke. And right now, today, we have 36 devices that will work on Fluke Connect. By the end of 2017, we're going to have 100 different meters of all different types that will work with this application. And we have the ability to talk to 10 different devices at the same time. So allows the end user a lot of flexibility in terms of where and how they make their measurements. Allows you to operate outside the arc flash zone and lock out and tag out the circuit, so the end user is standing on the other side of that panel safely and making his measurements. And I find this a great way to start doing a predictive maintenance program and start to document all those readings that you're taking down by hand. So you can see electrical, temperature, current energy, thermal images, vibration tools all have this capability in them now. So the thermal piece is the last portion I wanted to talk about. So thermally, it's a great idea to go measure from a distance. So thermal imagers allow us to do that, allow us to see the electrical heat or overheated component or overheated transformer without having to be right next to it. And so the idea that I can shoot from some distance away, anybody can take a picture, we can get an idea what the heat content is, and see if it's operating within the manufacturer's acceptable boundaries or not, and also download the data and create reports. For a lot of customers, the idea of seeing the invisible as a visible display. So I can see the heat content of why that breaker on the reading to the right, or the picture to the right, one from the right, is overheating and tripping, or why my three-phase motor is stopping and overheating on my drive is tripping, or any number of occurrences might be happening as a function of overloaded circuits that are showing up as an increase in temperature. The safe way to do this are use of what are called IR or infrared windows. And an infrared window affords me the ability of mounting a permanent window, which is a pure crystal window, arc flash rated to 63 Ka, and we are good up to 72,000 volts. Mount that on the panel permanently, as a peephole, if you will, and have a cover that can be flipped down or pulled to the side, so I can stand outside the panel and shoot through that window and see both thermal and visible light, and do it from a safe distance, again, without having to put all the PPE gear on and without having to open up that panel door every time. So we mount the window, keep the panel door shut, and look inside that enclosure as a way of keeping you outside the arc flash zone. So the last part I wanted to touch on was being trained. So under NFPA 70E, your employees are supposed to be trained to select the appropriate equipment for the task, demonstrate how they're able to use it, interpret the results, understand the ratings, perform a visual inspection, and perform operational verification on a known voltage source. So we at Fluke can do this with you two ways. Obviously, we're giving you an overview of how we do this. But we would love to get an invitation from you folks if you'd like us to do this as an on-site electrical measurement safety class for your entire crew. We can come on site and do that with our Transcat being our partner to arrange that with the sales engineers such as myself, and there's quite a few of us across the country that do this on a regular basis as a value-added service. So let Nicole at Transcat know that. They're going to be sending out a survey form and a feedback form, and if that's your desire, we'd love to hear back from you. And with that in mind, we'll leave you one last item, what we call a test equipment safety audit. What this really basically is a way of giving yourself a scorecard on your meters. Are they in full compliance with NFPA 70E? And here's all the categories you need to test it across or look at it. We do have an audit sheet as well that we can send out to you to help you do this, called a safety audit. It's on an Excel template, and it's something that's going to be offered up to you as well if you'd like to do the entire list of all the equipment you have and do it at one shot. We can help you with that and figure out whether you're in compliance or out of compliance in all the test equipment that you currently own. So anything that gets involved with an energized circuit has to have the proper ratings on it. Any type of equipment at all that's used as a measurement or testing device. So that includes quite a few different categories. So we appreciate the time today, and hopefully this was informative and worth your time. We're looking for opportunities to continue the conversation with you through Transcat, but appreciate your time here today to listen through, and hopefully we created some insight and some value for you here today. We look forward to talking with you folks again soon.
Thank you, Kurt. If you go to the next slide, I'm going to open it up to questions, but if you go to the next slide, there is a promotion. I just wanted to make everyone aware of. Right now, there's a limited time offer. If you buy any Fluke items over $250, you qualify for a free gift of various tools and other items. Go ahead, Kurt.
Yep, and this is great.
I'll continue.
So you can download this. Go ahead. I'm sorry, Kurt. We lost you. So let me just finish. So this gift with purchase is valued up to $1,350, and if you go to transcat.com/deals, you can get the full details and redemption information. And Kurt, if you go one more slide for me. Thank you. So everyone, we're going to send out a copy of the presentation and the recorded webinar, but my contact information is here if you have any questions or would like to talk to us about any of Fluke interests. In the meantime, I'm going to go to the questions. Oh, someone asked if we'll be sharing copies. Yes, we're sharing copies of the presentation. We'll be sending that in the next few days. The next question. What does NFPA 70E stand for, and why is it important? Kurt, can you answer that for us? Oh, yeah, that's right, yeah. National Fire Protection Association. So this is their safety standard. It's been adopted, the de facto standard that the insurance industry is now using in the commercial and industrial marketplace. The importance of that is they're actually making customers who are operating their own electrical connections and responsible for their own electrical distribution to be able to conform in a safe manner. So there's quite a few rules and regulations around the use of not only test equipment but PPE and a variety of other things. And it is actually one of the metrics that customers are getting judged by when their insurance company is setting their premiums. Where you have a large congregation of people, I'll use a hospital as an example, the insurance industry is concerned about fires running through the walls of the building and how fast can you move people out of that building. So they're trying to limit their amount of liability and getting you, the end user, to operate in a much more safe manner to eliminate the possibility of such explosions and fires.
Okay, thank you. You know, Kurt, someone asked, and we didn't address this before the webinar. Can we? They asked if they can get a certificate, a CEC, for this webinar, which I assume is a training certificate.
Yeah, CEUs or CEDs, or however you refer to them, are certified educational units or degrees.
Credit. Yeah, certified credit.
Credits, yeah. Unfortunately, no. We do have folks that are offering classes like this that are offering credits for those classes, but we at Fluke are not. So I apologize. But the content is still more than worthy of knowing and understanding, because if you would go into a class such as this that you pay for, it's a lot of the same content. So understanding it ahead of time before you take a class and get a CED or CEU, you're going to be ahead of the game.
Okay, here's another question. Is NFPA 70E the safety standard for the Canadian market?
For what market, I'm sorry?
The Canadian market.
I'm not sure. I'm not sure if they have the same standard up there or not. I know it's for the U.S. market, but they may have something equivalent to that. Nicole, if you like, I can get a hold of Eddie Zompka, who's my counterpart up in Montreal.
Yeah, and we'll get back to this gentleman. I have his information.
Yeah, we can ask him that question. I don't know.
Okay. What are the 4 category ratings for electrical meters, and what do they mean?
Okay. So the 4 ratings, again, were Cat 4, Cat 3, Cat 2, and then I verbally described Cat 1. It wasn't shown. So these are the environments in which the meter is going to be used, the physical environment where they're used. Are they used outside? Are they used inside? And what amplitude of voltage is the meter going to be exposed to, as a way of verifying that you've got the proper meter for the proper application.
Okay.
Okay.
How is the level of PPE required to be worn by the person using the meter in a live circuit determined?
Okay, so that's determined, again, through NFPA 70E as categories 1, 2, 3, and 4, which was on one of the slides I showed earlier, and calls out the level of PPE and the calorie rating on the clothing, and the level of number of layers of clothing that must be worn. So it is called out in. Oh,
I'm sorry. Go ahead.
It's called out in NFPA 70E under PPE.
It looks like one of our customers might have answered the question of the last person, because they sent a note that says CSA Z462 equals NFPA 70E. So I'll throw that out there. We'll still verify with our Canadian contacts, but thanks for throwing that out there.
Thank you. Appreciate that.
Okay. What are the 3 actions a meter user needs to take every time they use the meter before going into a live circuit and determine it to be de-energized or safe to work in?
Okay, so the 3 actions are do a continuity measurement, resistance measurement in my test leads to make sure that they're not broken and they're working. To be able to test my fuse, as was illustrated in one of the slides, to make sure that in the event I miswire the meter, that the fuse is in fact working. And then do the 3-point test method of live, dead, live. So again, we're going through a known live circuit, or if that one's not available, using something along the lines of our Fluke PRV 240 proving units as testing against the known live circuit. Then going out to the target circuit, which is at this point been de-energized, verifying that it's de-energized or dead, and then going back to the known live circuit again. So we're testing leads, we're testing fuse, doing a live, dead, live test verification with use of our meter.
All right. Where and what are the 3 markings on the meter to signify that the meter is properly rated for the environment where it's going to be used?
So if you recall, we were talking about category ratings, and the location of these would be next to the bolt and common connections on the face of the meter. If it's something like a clamp meter, it might be in the bottom. If we need to plug it in the bottom, you might see them there. But again, the minimum acceptable rating is a Cat 3 600 volts. If you're going to be using it outside, that would be a Cat 4 rating. There's 2 different rating levels. There's 600 volts and 1,000 volts. And then on the back of the meter is the third-party safety agency rating. So it will either have UL, CSA, or TUV as the third-party safety agency that has listed the meter and approved the meter.
Okay. There's one question that I'm going to just have you answer privately. So that's about it for our questions. So it concludes our time for today. If anyone has further questions or would like to find out more about our product offering, please contact at 800-800-5001 or on the web at transcat.com, or you can email me directly. My information is on the last slide, but it's nvanwert@transcat.com. Thank you for joining us today. We hope you got something out of the presentation and that you continue to join us for future Transcat e-learning webinars. Thank you, Kurt.
All right. Thank you.
Thanks,
Bye-bye now.
everyone.